The next part of our division section is learning about what's called the remainder theorem. Now, if you take a look at this, it's pretty wordy, but let me walk you through it. The first part of it here is simply setting up what division looks like. So if we are dividing by a binomial, in this case the x minus c, we get the q of x they are calling the quotient. That is the result after we divide. Plus, we might have some remainder. That's what they're calling r of x. Remember, when you divide normal numbers, let's say we have 15 divided by 4. We would get 3 because 4 goes into 15 3 whole times, plus the remainder, which is 3, over what we divided by. Rewriting this, the function was 15, what we divided by was 4, the quotient, or the result, was 3, plus we had a remainder of 3. So 15 equals 4 times 3 plus 3. That's true. That's all they're saying here, but with function notation. When we did our synthetic division with a binomial, anytime we got a remainder, our remainder was a constant. There was never any variable piece to it. So we're dropping the function notation piece here and just saying r is a constant. The next piece says, well, let's say x equals c. Let's say we are evaluating our function at a given value of x, which is, in this case, c. Once we substitute c in, that first piece goes to 0, which means when we multiply by the quotient, that goes away, and the function evaluated at c is the remainder. So what the remainder theorem says is that you can evaluate a function using synthetic division, and the remainder would be the result of if you substituted that value in for x. Finally, if you substitute in and you get a remainder of 0, that means that you found a factor of the function, and if you substituted that value in, you would get 0. So let's see how this works with some actual functions, and hopefully that remainder theorem will make a little bit more sense. First of all, we have a binomial, so we can set up our synthetic division using those coefficients 1x cubed plus 5x squared plus 5x minus 2, pulling that positive 2 out of the asylum and putting it on the outside. Bring down your 1, multiply by negative 2, add, multiply by negative 2, add, multiply by negative 2, add. So the question says, what is the remainder? In this case, our remainder is 0. And what does it mean? It means x plus 2 is a factor of x cubed plus 5x squared plus 5x minus 2. It also means that the function evaluated at negative 2 is 0. So this next one is asking us to evaluate the function for a given value. Notice this time that 3 is not grouped with the x. It's not the binomial, so we put that on the outside as 3. There's no need to pull it out of the asylum because it's not in 1. Setting up our coefficients, 2x to the 4th, 0x cubed, don't forget those placeholders, negative 15x squared, negative 10x, positive 5. Using our synthetic division, we drop down the 2, multiply by 3, add, multiply by 3, add, multiply by 3, add, multiply by 3, and finally add. Our remainder is 2, so what that means is when we substitute 3 into the function, we will get a value of 2. As a comparison, subbing that 3 into the function and evaluating it how we normally would, we would do 2 times 3 to the 4th minus 15 times 3 squared minus 10 times 3 plus 5. 3 to the 4th is 81 times 2 is 162. 3 squared is 9 times 15 is 135. 10 times 3 plus our 5. Adding and subtracting left to right, 162 minus 35 is 27. 27 minus 30 is -3, plus 5 is 2. We get the same answer, but I think you'll agree after seeing this, the synthetic division gets us the answer much more quickly and easily. All right, so let's tackle this fun notation here. We saw how it worked with numbers, and it was fairly straightforward. It is fairly straightforward with the function as well. So we're going to set up our synthetic division. We have 3x to the 5th plus 0x to the 4th minus 1x cubed plus 2x squared plus 0x plus 6. Be very careful you don't lose any of those powers. K equals -4. Notice again, it is not in the asylum. It is not grouped with the x, so we keep the value that was given to us. Drop the 3, multiply by -4, add, multiply by -4, add, multiply by -4, add, multiply by -4, add. I should have given myself a little bit more room. Multiply by -4 and add. All right, so here's what the remainder theorem tells us. It tells us that the function that we were originally given would be equal to what we divided by, now we're going to put that -4 into the asylum, times the quotient or the result of what we got when we divided. Remember to drop a power when you start adding those variables back in. And running out of room here, so then plus the remainder. So I'm just going to have to write that on the next line. So if we multiplied this out, and I am not going to demonstrate that this one works, if we multiplied those two out and then added the remainder on the end, we would get our original function back. Let's look at that one more time. Setting up our synthetic division, -1x to the 4th minus 7x cubed plus 1x squared plus 0x minus 9. Again, that 3 is not grouped with the x. Drop the -1, multiply, add, multiply, add, multiply, add, multiply, and add. Setting this up, our function equals what we divided by, this is where that 3 goes in with the x and becomes opposite, times the result, remember to drop a power, and adding the remainder on the end. And you have 2 you-try questions. Please make sure you let me know what questions you had on this so I know where to start our class discussion.